Okay, this video is about kinetic energy. So what is kinetic energy? You may have heard of it in P1 as one of the 9 types of energy. So it's basically any moving object has kinetic energy. A plane, a bus, you, anything that's moving at all. And because it's an energy, it's measured in joules. Okay, the symbol for that is a capital J, not a small j. You will lose marks if you do that. And 1000 joules is 1 kilojoule. You need to be careful with this because they may give you it in kilojoules but want you to convert it back into joules for the question, so they're quite sneaky. So how do you calculate it? This formula here, which to some people looks a bit nasty, but it's quite nice, it's fine. So EK, some people say, why is it EK, not KE? Well, it's because it's an energy, it's energy kinetic, measured in joules. Half is just a half, believe it or not, just 0.5 in your calculator, that's all it is. M is mass, as we know, measured in kilograms. Again, if they give you it in grams, they're being sneaky, change it into kilograms. And velocity, okay? But it's velocity squared, so make sure you do that in the question. And velocity is just measured in meters per second. So how would you do it? So if the question said, a car is travelling at 6 meters per second and it has a mass of 1,500 kilograms, what is the car's kinetic energy? This is a really straightforward question for them to give you. That's why I've said 2 or 3 marks. It would be 3 marks if they didn't give you the unit, 2 marks if they did give you the unit. Straight away, what you need to do with calculation questions is always write out the formula. I don't care that it's on the front, you need to write out the formula. And then the next thing you need to do before even thinking about rearranging is to input the information you've been given. So half, still a half, mass, find it in the question, 1,500. Velocity, find it in the question, 6, but don't forget to square it, okay? It's so important. Then what I would do is work it out. So half times 1,500 times 36, and then find your answer. So 27,000 joules. And that might seem like a lot, but it really isn't that much in the great scheme of things. That's really straightforward. However, what you may get as well is kinetic energy in different situations. So they do really like to compare it to gravitational potential energy. So the rule here, the golden rule, is that the loss of gravitational potential energy is equal to the gain in kinetic. You're not told this in an exam, and it's if we presume there's no other external factors such as friction or air resistance. Okay, so it's in an idealistic world, not on Earth, but we use it for the questions. So the first part of the question may have asked you, for example, to work out the gravitational potential energy of, say, this football on the top of the cliff. The question would give you the mass of the football, it would give you the gravitational field strength, which is just 10 newtons per kilogram, just learn it, and the height here would be 10 metres. So you would have worked this out before, probably just for 2 marks, and you would have found the answer is 50. But because of this, we know that, okay, so if it has 50 gravitational potential energy at the top, it has 0 kinetic energy because it's not moving anywhere yet. Halfway down, it's going to have lost half of that gravitational potential energy, so that'd be 25. So we know that energy can't be created or destroyed, only transferred. So the other 25 is now kinetic energy. Right before, now I'm talking like a whisker, before it hits the ground, this is going to be 0 gravitational potential energy, and all of that, in an idealistic world, has been converted into kinetic energy, okay? You're not told this, you're just presuming this, you have to know this. The next question might then say, what is the maximum possible speed the ball could reach if no external factors apply, okay? Now then you go, what? Speed? What are you talking about? You haven't given me anything there, but you need to remember this little fact. Loss of gravitational potential energy equals gain in kinetic. So, you already know this because you've just worked it out effectively. You know this, it's just 0.5. You know the mass from the question to begin with. It won't repeat that again, it's already told you. And velocity is what you're trying to find because they do love to talk about velocity and speed in the same terms. Yes, they're both measured in meters per second, but velocity is speed in a given direction. So it's a little bit sneaky again of them to do that. So all you would do is then go 50 equals half, 0.5, times 0.5, which is the mass to begin with, times the velocity squared. Well, we need to find this out. So put it into calculator, would be 50 equals 0.25 times v squared. You need to get this on its own, so you need to bring down your 0.25, so it would be 50 divided by 0.25, which is the same as times in by 4. So it would give you 200 equals v squared. Well, we don't want v squared, we want v. So you just square root, your 200, which would give you that v equals 14.1 metres per second, okay? I have done it to 3 significant figures, which they do tend to ask for. So don't get caught out by this question, because a lot of people would just leave it out because they wouldn't know. A lot of the time, if you're not told information in this, look at the one you've just worked out. As well, if it had been a bit of a numpty and I'd worked this out wrong, say is 60, but used it correctly within this, I'd still get 4 marks. It's called error carried forward. So I hope that helps.